Udah bisa dimulai, Prof?
Yes, tunggu sebentar, saya mau tutup-tutupin ini. Okay, let's start.
Okay. Ya. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Istiqomah Agusta. It's a precious chance for me to be your master of ceremony for this very special occasion today. First of all, let's say thanks to Allah who has given us guidance, happiness, hope, and mercy so we can attend and participate on this very special event without any obstacle. I would like to welcome our guest first to Vice Dean 2 of Faculty of Medicine, University of Indonesia, and also one of our speaker today, Dr. Anis Karuniawati, microbiological specialist, consultant, PhD from Department of Microbiology. Welcome, Doctor. Our head of Master Program in Biomedical Sciences, Faculty of Medicine, University of Indonesia, Professor Dr. Septelia Inawati Wanandi. Welcome, Professor.
Thank you.
To Coordinator of Microbiology Concentration, Master Program in Biomedical Sciences, Faculty of Medicine, University of Indonesia, Dr. Fitria. Welcome, Doctor. And to our special guest, our visiting professor from Faculty of Health Sciences, University Kebangsaan Malaysia, Professor Dr. Nur Azia Muhammad Zin. Welcome, Professor. Assalamualaikum. Yeah. And welcome to all participants to e-forum BIOMEDIKA with special topic antimicrobial resistance. This program is held by Master Program in Biomedical Sciences, Faculty of Medicine, University of Indonesia, supported by visiting professorship program DPASDP, University of Indonesia. Okay. In this event, we will have several agendas as follows. First, we will have welcome speech from Head of Master Program in Biomedical Sciences, Faculty of Medicine, University of Indonesia, followed by first topic, which will be delivered by our visiting professor, Professor Dr. Nur Azia Muhammad Zin, and followed by second topic, which will be delivered by Dr. Anis Karuniawati. And after both topics, we will have discussion session, which will be guided by Dr. Fitria. Okay, before we start this event, I would like to inform several important things. During this event, all participants have to mute or turn off the audio. And should the participants have any questions, please write it down in the chat room, in the Zoom, or in the comment section in the YouTube. And third, regarding the e-certificate will be provided only for those who fulfill the requirements. First, should be attending the events through Zoom channel, should turn on the video during the event, should register in the registration form before the event, and also should fill the attendance form, which will be distributed during the event. Okay. As our first agenda, we will have the welcome speech from Head of Master Program in Biomedical Sciences, Faculty of Medicine, University of Indonesia, to Professor Dr. Septelia Inawati Wanandi. The time is yours.
Thank you very much, Dr. Istiqomah. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First of all, I would like to welcome the honorable guest as our visiting professor, Professor Nur Azia Muhammad Zin from University Kebangsaan Malaysia, and the Honorable Dr. Anis Karuniawati, the senior lecturer, associate professor from Department of Microbiology, Faculty of Medicine, Universitas Indonesia. Dr. Anis also the vice dean in our faculty. We are delighted to have both speakers who are experts in the field of microbiology, particularly in antibiotic resistance, that we will discuss in this forum today. On behalf of our study program, Master Program in Biomedical Sciences, Faculty of Medicine, Universitas Indonesia, I would like to express our sincere gratitude to the both honorable speaker for sharing us your expertise today. E-Forum BIOMEDIKA is a regular scientific seminar held by the Master Program in Biomedical Sciences, Faculty of Medicine, Universitas Indonesia, for our students and also for all the biomedical scientists in Indonesia in general. Today we have about 364 this morning. I watched that 364 registered participants, and we also opened this forum electronically through our YouTube channel. The Master Program in Biomedical Sciences, Faculty of Medicine, Universitas Indonesia, was established in 1979. Our program is the oldest graduate program in Universitas Indonesia, and for the biomedical science program, also the oldest in Indonesia. Our vision is to be the one of the leading biomedical education center in Southeast Asia and focus on translational research. After assessed by the ASEAN University Network last year, this year we received a funding from Universitas Indonesia for the international academic reputation through several collaborative programs, such as this visiting professorship program. Thank you to DPA SDP UI for facilitating us with this funding. We are very grateful that Professor Noor Azia has accepted our invitation to be our visiting program in microbiology field, and we also plan to invite Prof. Nora to be the thesis examiner in December, and also we will have a board meeting with Prof. Nora for research and academic collaboration. Actually, UI and UKM, Universitas Kebangsaan Malaysia, especially the Faculty of Medicine, have a close history. Our late professor and senior lecturers from preclinical departments have used to be the visiting lecturer in UKM during the first year of establishment of Faculty of Medicine, UKM. Since 2005, an annual scientific conference has been held by UI, UKM Medical Center, and also University Brunei Institute of Medicine, which is called Malindo Bru, or lately called as MIB. Last year, the 11th MIB was held in the Faculty of Medicine, Universitas Indonesia. I hope that the involvement of Professor Noor Azia through visiting professorship program could enhance and broaden the collaboration between UI and UKM to establish the regional standard quality of master's graduate in biomedical sciences. To all audiences, thank you very much for your participation in the E-Forum BIOMEDIKA. Hope you enjoy this meeting and have an inspiring insight and fruitful discussion from both speakers. Have a good day. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Ina, for the speech. And before we next to our main session, we would like to take photograph together. For all the participants, please turn on the video. We'll take 3 times take, yeah. Okay. Mbak Adin?
Okay, the first take. 1, 2, 3. Okay, the second one. 1, 2, 3. The last picture. 1, 2, 3. Okay, thank you.
Thank you.
Okay. Yeah. Now it's time to move to our main session, which are the lectures from both speakers. This session will be guided by the moderator to Dr. Fitria. The time is yours.
Terima kasih. Thank you, Dr. Isti, for the opening the today's e-seminar. So, good morning. Assalamualaikum warahmatullahi wabarakatuh. Before the presentation begin, allow me to introduce the speaker for this seminar. So, our first speaker is Professor Dr. Nur Azia Muhammad Zin from Program of Biomedical Sciences, Center for Diagnostic, Therapeutic, and Investigative Studies, Faculty of Health Sciences, University Kebangsaan Malaysia. And I received such an outstanding curriculum vitae for Professor Nur Azia and try to recap it in a short way. I hope I didn't do it in the wrong way. Prof. Nur Azia completed Bachelor of Science in Biotechnology from University Putra Malaysia in 1993 and doctoral degree in Bacteriology from University of Strathclyde in 2001. During her professional career, Prof. Nur Azia received many international and national recognition. I only can recap it and try to pick in the best recognition that she received, such as leader of project collaboration with Seoul University in 2014, also a certified trainer for zoonotic diseases under the fund of USAID and Southeast Asia One Health University Network, and also project leader in Malaysia One Health University Network in 2016 in first group of National Antimicrobial Resistance Committee. And of course, Prof. Nora has around 110 publications in journals, proceedings, and books. Prof. Nora's current research interests are in anti-infection from microbial metabolites, antimicrobial resistance, and infectious disease. To shorten the times, I will give the presentation time for Prof. Nur Azia to deliver the first speech entitled Antimicrobial Resistance, One Health Approach, Current Scenario and Research on Finding Antimicrobial Agents. To Prof. Nora, your time to presentation is around 60 minutes. Prof, the time is yours now.
All right, thank you very much, Dr. Fitria, for extensive background. I'm sure that all of us have capable of doing this. Yeah, this is all, inshallah, all for good for our nation to share the knowledge. Yeah, I'm not saying that I'm the expert in this field, but I always want to share my knowledge, my experience, and my research on this particular topic. I'm surely the audience, the students from medical background is much more expert than me in this particular field, maybe. And I think Dr. Anis and Dr. Siptelia also have your own capability, right? So today, this morning, I just want to share my experience, yeah, my knowledge on this antimicrobial resistance. And if I can put up my presentation. Everybody can see my slide now? Everybody can see my slide?
Not yet, Prof.
All right, okay, right. So as the title is the antimicrobial resistance, I'm going to divide my talk for three particular three particular area or the three big team is the first of all I will discuss about how the One Health University network approach can be used in to combat this problem. And of course, I'm going to discuss a little bit about the current scenario in Malaysia as well as in Indonesia maybe, or in the other country. And of course, after that, the third part is the research, how we run, how we carry out the research on this particular field to find the antimicrobial agents to combat this resistance. Right, so everybody can see my second slide?
Not yet.
Not yet,
Not
Prof.
yet, Prof. Not yet. The
The
we
slide we
haven't
cannot
seen your
see.
slide.
Not yet, so how about now?
Not yet. Maybe you have to stop share first and start again.
Okay. You cannot see my slide. The second slide, not yet.
Not yet.
Not yet. The first slide also not yet.
All right. So I should
stop share first.
Just hold on. You cannot see the slide yet?
Not yet.
So I should here just now is here. Okay. Share. All right.
Okay.
Yeah.
All right. So now you can see the second slide?
Yes.
Yes. Yes.
Yes, Prof.
All right. Okay. So can you see the third slide?
Yes.
Yes.
Yes, we
All
can.
right.
Yes.
All right. So thank you very much. Okay. So as you can see from the slide, we have several scenario on the antimicrobial resistance, which is a natural occurring phenomena due to the bacterial adaptation itself. We will go to the what you call it, to the fundamental basic concept of this antimicrobial resistance first. So this phenomenon is due to the, let's say, for the overuse of the drugs itself, or the misuse, is not appropriate prescriptions of the drug, and of course the frequent antibiotic usage over the long period times. This will put the selective pressure that allowing the antibiotic resistant bacteria to survive and multiply. And if this process or this phenomena is not being checked, or is ignored by GP or by the health people, the infection disease will be untreatable, leads to the more severe illness and increase in the mortality. So this has been tabled by the WHO. It is one of the primary public threat in the 21st century. And at the moment, the annual death due to AMR is could reach 10 million by the year of the 2050. This is predicted by the WHO. All right. So my third slide now, everybody can see?
Yes, Prof.
All right, good. So for the One Health perspective point of view, this is the approach that been proposed, I think, in the early 21st century. This will acknowledge the health of human, animal, and environmental is closely linked together. And I'm sure Dr. Anis will talk more about this later in the Indonesia approach or Indonesia experience. But now for me, I would like to introduce how we in the safe Southeast Asia One Health University Network, and of course this SEAHUN, the short form, is including 61 university in the 7 countries, including Malaysia and Indonesia. They have IndoHUN, Vietnam they have WuHUN, and so forth. So this SEAHUN is a big university network that contains all the 81 universities for the 7 countries in the Southeast Asia. So the critical elements, as you know, in transforming the current and future workforce, is in, especially in the AMR, is to ensure that we have the prepared, well organized to challenge the emerging public health. Yeah. And of course, this is the AMR is global issue because it's involved from human to the livestock, and including the environment is how the interlinking between the animal food as well as the how human produce the waste and leave it to the environment, contaminated environment, together not only the poisonous waste but as well as the antibiotic residue to the river, to the environment. So this is the approach that been proposed, that been used as a guideline for the SEAHUN as well as for the MyHUN and others university network in the whole Southeast Asia. So as we know that the emergence of antimicrobial is starting in the bacteria. The bacteria contain the genes that can been used for their own purpose maybe, but they carry the particular genes that can be resistant to many antibiotics. So how is the types of resistance observed in bacteria then? Yeah? By definition, we have is either intrinsic resistance or acquired resistance. So for the intrinsic resistance is might be from the natural trait itself, and it's between the species or genus of the bacteria. So how they required they acquired the resistance. So the strain may develop the resistance which was previously they are very susceptible. Like say for the Staphylococcus aureus, they have the MSSA, the methicillin susceptible Staphylococcus aureus, but now they become develop the resistance. It's become MRSA, the methicillin resistant Staphylococcus aureus. So it's acquired resistance only present in only certain strain of the species or genus. So as you know, for the students, you have learned from the undergraduate level maybe, we have various mechanism of resistance. It's from the structural or function of the bacteria itself that allowed to tolerate to be insensitive, but they can acquire the resistance through the vertical transmission. Let's say the gene mutation, and some of them will get the induced gene mutation by horizontal transformation, transduction, from species to species, and the transduction can conjugation from mobile element, let's say from the one plasmid of the bacteria to another plasmid of the bacteria. It can be happen. Right, here is from the USH slide that I obtained. They categorize as between the antibiotic targets and the antibiotic resistance. Some antibiotic like beta-lactams, antibiotics, vancomycin, they targeted the cell wall of the bacteria, and some rifamycin, for instance, the antibiotic they use for maybe for the Mycobacterium tuberculosis infection, the target is the RNA or DNA synthesis, and so forth. So different antibiotics have their own target, but how the resistance taking place, from the aminoglycoside for instance, they have efflux mechanism, that can made them resistant to the various antibiotics like tetracycline, beta-lactams, macrolide, and so forth. And of course, by the mechanism of the immunity and the bypass, the target modification, inactivating enzyme. So they have cleverly, the bacteria have find a way to make them resistant for each and every antibiotics. So because of the approach involved of the animals as well as of the environment, so we have to have the relevance, how the animal production play a role in the emergence of antimicrobial resistance. What does evidence so far that we have? As we know, we have a lot from the papers, current publication has been reported. They have a lot of the emergence of bacteria in the livestock population. In the livestock population is connected to the AMR emergence, and after that it will colonize and infected to the humans. Some studies show that the most emergent of antimicrobial resistance in bacteria is originated from the antimicrobial usage, or short form AMU, in human. So the majority of AMR bacteria in the livestock seem to originate from the AMU in the livestock, meaning to say that the farmers, the the chicken breeder use lots of antibiotics for the growth hormone, actually to make it the chicken growth instead of maybe 3 months, but with the supplement of antibiotics in the food, they can grow the chicken just only maybe 1 month or shorter for the profit purposes, and they use a lot of the antibiotics. So the usage of the originated from the livestock is become the emergence of this antibiotic resistant to the human. Right. So this from the point of view, the in most cases, both animal and human, is a positive association was found between the volume of antimicrobial usage, consumption, and the prevalence of the resistance to the exposed bacterial population. So of course, the consensus whether there are routes for spillover of AMR between the bacterial population and human, between the human and food producing animal, there are in both direction, from human maybe to the livestock, and from the livestock to the human. There are also an issue on the potential role of the global travel and trade in the transboundary dissemination of the resistant genes. So it's a lot of contributing factor in this area as well. So this is an example of the sources for the AMR from the bacteria and the bacteria genes in animal production settings. Sorry, because we know that I know that some of the audience are medical doctor here, but we have to clear the concept is how actually the transmission of these resistant genes can be transfer from the animals to the human. Let's say, for example, the Campylobacter species, one of the pathogenic bacteria, is a lot of them resistant towards the fluoroquinolones, fluoroquinolones, and then is commonly observed in the gastrointestinal infection. So we now know that this poultry is one of the sources for this Campylobacter that might have carry the genes that are resistant to the fluoroquinolones. So there are research reported there are other source of the human infection coming from the raw unpasteurized milk and contaminated water. So for the Enterococcus, for the E. coli, for the LA-MRSA, yeah, the large animal methicillin resistant Staphylococcus aureus, yeah, and then the Salmonella species, that the non-typhoidal, the gastroenteritis, yeah, gastrointestinal, that resistant to the cephalosporin, quinolone, tetracycline, and so forth. So it's coming from the many animals like pigs, cow, and the poultry. So is here is the diagram showing that how the antimicrobial usage in humans, animals, agriculture will result to the dispersion for the antimicrobial residue to the aquatic and terrestrial environment. I'm sure that Dr. Anis after this will elaborate more on this, how the eco health things are closely related to give to play important role in this resistance contamination. Right. Again, I'm not need to go to the detail for this, because this is between the agriculture as well as to the human, and as well as to the animals, wildlife, environment, and involve the agriculture. How these antibiotics resistance, antimicrobial resistance play important role from the livestock, from the to the contaminated meat, yeah, to the human, and then so forth, from the soil, and then and so forth, right? So the spread of the AMR between the animals, what we know so far, as I mentioned earlier, the both pathogenic and non-pathogenic resistant bacteria can be transmitted from the livestock to the human via different routes, yeah, from the food consumption, direct contact with animal, direct contact with waste, yeah, and then vomits. Yeah. So any mechanism that helps spread the bacteria has the potential to transfer the bacterial resistance, because the contaminated bacteria is already carry the antimicrobial resistant genes. Yeah, they are with them in the plasmid, or in the DNA. It's just that the genes, the evolvement of the resistance is already with the bacteria. So the consumption, the contact, is all can spread the transmission. Right. Some of the what you call it, the booklet available in mitigating this problem. We have the FAO, food agriculture in the United Nations 2016 to 2020. Yeah, we have the global action plans, yeah, by WHO, and in Malaysia we have this Malaysian action plan for the antibacterial resistance from the 2017 to 2021, and this is from the Ministry of Health. I'm sure that Indonesia also have your own guideline, your own action plan based on the WHO and FAO guidelines. So these are all the ministry in our country looking for these problems. Take this problem very seriously, and with the pandemic of the COVID-19, everything, the emerging of the new diseases, emerging of these resistance, many resistant, isolate, and so forth. Right. So this the involvement, surely involvement for this to combat this problem, of course, is involved of this the government itself, yeah, the awareness coming maybe from the educator, from the lecturer, public health people, so they have a surveillance and monitoring program. I'm sure that how we can hear after this from Dr. Anis maybe, how this can be how the work done by Indonesia counterpart to combat this, involving all the different aspect, different people, different group. Like for the Siahun, we have the academician, we have the researcher, we have the ministry people, and we have the veterinary department come close together and developing the curriculum, developing the new module for the students, developing the new approach, and developing the policy to suggest to for the ministry level, how we can together what you call it, cooperate together. So this is how the beauty of the One Health network, university network, not only involve the academician, not only involve the veterinarian people, but also all the wildlife. Even we have some collaboration with the wildlife people department, wildlife department, looking this aspect. We have the huge rabies outbreak last time, so veterinarian before this just only people working maybe in silo, individual basis. Veterinary just only look at the animal aspect, medical doctor only looking at the human aspect, and then scientists only doing the research and just keep in the cupboard, for example. So now it's opening eye for me as well. Before this, maybe for the last 10 years, 15 years, I'm working only how to I'm going to share my research, just only getting publication, getting the students, graduate, the postgraduate student, research PhD student, and after that publication and thesis and stop. So how we contribute back to the community, how we get this done at the community level, how we should educate people in these particular things, how we should go to the the community-based research, something like that, so can be directly being used by the people. So as a scientist, we only look at the one aspect. For me especially, I'm talking about myself actually, it's very narrow, but when we come together with people from different area, different approach, veterinarian, wildlife people, policy maker people, you can broaden the thinking, the way of mindset is, oh, you should do this, you should do this. Not only papers and papers, not only graduate student, but also the impact to the community, to be used directly to educate. Even the school children, talking about the antibiotic to the school children. Yes, we can do that actually, because one of the aspect that I was in Yale University in 2015. We developed the curriculum to find we call it a small world. Now it's changed a tiny world. It's talking about the finding the microbes from the different sources, from soil, from plant, and produce the antibiotic properties. So we bring the small children, go find at the backyard the sample and get the colony of the bacteria and how they can kill for other bacteria, something that give them some exploration. So this is how they produce the antibiotic, how the people getting infected, how the people can be cured by the antibiotic and so forth. So this is how the important roles that can be played by us, by academicians, surely. All right. So this is one of the photo that we have in Chiang Mai 2015 under the Siu-Hun training. So we have particularly concentrated on the AMR. So we developed the module for to be shared with the participants. We have the TOT first, one week training for trainer, together with the USA people's expert, Professor Jeff Bender and Stephen here. Catherine also here. So they have the training first, and after that we have the people all over the Southeast Asia University, the academic staff, the postgraduate student join us for another 2 weeks of workshop. So we have the like model, we have like games play, role play, how this antimicrobial, we have the like press conference, how this AMR can be huge, what you call it, emerging diseases. Yeah? So that kind of thing, not only learning for the how the mechanisms, how the antimicrobial resistance taking place, but also how we can combat with the combination, with the collaboration with all the people in the different sector. And another one we have in Nha Trang in Vietnam, the same year, in one earlier just now, and earlier in the year, and the second one is in December, I think. So also under the CEOHUN and then under the fund by the USAID, how we can similar courses but from different group of people. Yeah? So it's about 1 week training as well for them. All right, so now we go to the second part of the for the lecture about the research on NMR. Yeah, AMR, that link between human animal agriculture. How the people in the whole world looking at this area for concentrating on the AMR. Can I know how many minutes to go? I have Dr. Fitria.
Yes, Prof.
How many minutes I have?
We will stop until around 10:45.
All right, okay.
So we will, yeah.
All right, good. So this is my second part of my lecture sharing session on the AMR, that link between human, animals, and agriculture. Right. So the first of all that people are worrying about this, the presence of the MCR1 resistant genes, yeah, MCR1 resistant genes that lead to the ban agriculture use of the polystyrene. So with this particular genes presence, make the bacteria resistant to the polystyrene, the last resort of the antibiotics. This is the widely used animal production actually in the whole world, Europe. So it is resistant is likely spread worldwide. Right? So it's starting spread in China to Africa and in the food supply. So they have at least 3 studies reported in the Lancet journals in the between 2012 and to the 2013. They what call it, get the about 2,000 people, Dutch people, that traveling from the November 2012 to 2013, and then found that 6 isolates that have this particular genes in E. coli. So this is the dangerous of the MCR genes. It's not only present in one bacteria, but it's a moving, it's a mobile, it's in the plasmid, in the mobile element that we can transfer from one bacteria to the other bacteria. They have in E. coli, they have in Salmonella. That is all carried the cholesterol resistant isolate. Yeah, so in this agriculture, they found that because it's coming from the used widely in the agriculture, so it should be banned to be used, to be used of the cholesterol in the agriculture anymore because of the transmission of the resistant genes. Yeah. Here is the has been 2020. It's a current publication on the biosafety and health. It said that this cholesterol resistant genes, yeah, is very prevalent, yeah, in the bacteria that common to the animal and human. The name itself is a mobilized, mobilized, meaning to say it is a mobile. It can be transferable from the one species of the bacteria and to the others. That's why we have to have find a very tremendous effort to stop this. This is becoming the multidrug resistance, that's been used widely in the agriculture, and then as well as the use in the for the veterinary medicine. And they have, of course, the emergence of plasmid mediated, as I said, based on the plasmid mediated cholesterol resistance in China. They have a molecular study as well as the fundamental what you call it, the microbiological study on this. They use different method, polymerase chains, different sequencing method, the PCR and sequencing method for the plasmid, and then of course the compare, the sequence homology modeling has been established, as well as this is confirmed that this is a Polymaxy resistant, that's been confirmed in the in vivo study using the murine type model. For in Egypt as well, they have this antimicrobial resistance in the Enterobacteriaceae, from the healthy broilers. So it's from the extended spectrum beta-lactamase producing E. coli. We have some. This is I think this is journal 2014. Is in India, in India, about the have not only for the MCR genes, but they have some E. coli resistant that been isolated from the food. 2014, they reported from India that they select 150 samples, from vegetables to the raw egg surface, raw chicken, different various samples, and they found that they concentrate only to the isolation of the E. coli, and they did the susceptibility pattern, and found that they have the at least 4% extended spectrum for beta-lactamase, ASBL, producer been detected from vegetable salads and raw chicken, raw egg surface and raw meats. So it is very important, to avoid this transmission by using the good hygiene practice. Some same in Malaysia. I'm not sure how Indonesia get this food poisoning bacteria. We have last year or last 2 years, we have the contaminated from Malay noodles, the salmonella food poisoning, and some of them carry the resistant genes. We have the noodles, the Malay noodles, we call it laksa. I'm not sure how in Indonesia we call it laksa. We have laksa here, but they have the boiled egg, as well as the fish sauce, fish gravy kuah. So they brought the noodles coming from the northern part to the western part. It's about 300 kilometers, 400 kilometers in the room temperature, carry in the car. So by the time reach Kuala Lumpur, it's already contaminated, and they have a huge family gathering, and it's got contaminated by salmonella. So and some of them carry the resistance genes as well. So this is how it's happened nowadays. People's a lot of Grab food. They have the last year they ordered the pudding, egg pudding by the Grab food. The Grab food may be exposed to the high normal temperature for quite a long time, and they contaminated because from the egg, you know, they prepare the pudding using the uncooked egg, the raw egg. It's very nice. Maybe I'm not sure. I never tasted, but the pudding is made from the raw egg, huge of the white yolk egg, and then people just get contaminated with that. Yeah? But by that time, it's no resistant genes been found. It's lucky enough. So this is how these is this people or we can get the infected food poisoning bacteria. Right. So another thing in Malaysia, even we have this is 2020, very current. In the UMK, the University Malaysia Kelantan research, they found that the MCR genes that encoded colistin resistant E. coli in the chicken meat, raw chicken meat, as well as the bean sprout. Hopefully by the time that chicken has been cooked, it's no more no more E. coli resistant colistin genes over there. So this kind of very easy to get contaminated with this bacteria that carry this particular resistant genes. This prevalence study was conducted to detect the presence of colistin resistant E. coli in the raw chicken and bean sprout. It's very, I know it's contaminated in German 2016 or 2015. 5 years back, also coming from the it's a contaminated E. coli 157, the hemorrhagic E. coli. It's coming from the bean sprout as well, from the vegetable. It's now it can happen. Before that, only people know that hemorrhagic E. coli 157, E. coli 157 just contaminated from the what you call it, the meat, not chicken but the cow meats, the burger. But now they are from the vegetables. Maybe the vegetables contaminated with the animal feces, but knowing that people in the Europe using how they produce the bean sprout is not using the animal feces as the fertilizer. But I'm not sure how is it being contaminated. But we know that the contamination coming from the vegetables. Right. So the result shows that 52%. Is from the raw chicken were positive, carry the resistant colistin resistant genes, and then the, it's a very but of course the more comprehensive and large scale study should be focusing on the possible sources of this gene resistant. Right. Another one is a bit old, I think 2012. The prevalence of the multidrug resistant in poultry farm in Malaysia. They have carried out this research that processing that 72% of Staphylococcus, and of course about the same 71% of the Pasteurella species. That's well resistant, multidrug resistant. So in poultry farms, in Selangor, in the Negeri Sembilan, it's nearby. We have huge KFC chicken farm, Ayamas, the huge big fast food farm, poultry farm, the Pizza Hut as well. They are getting the chicken from the farm, nearby the Selangor and Negeri Sembilan. But you can see here from the finding this huge, more than 70% of the isolated bacteria is the multidrug resistant, carry the genes that multidrug resistant. All right, a little bit about the current scenario in Malaysia based on this national surveillance for this antimicrobial resistance that we have in 2019. The 2020 report is not coming yet, maybe because of the pandemic. Still not completed. 2020, maybe the report only we can get another year. So maybe for the 2020 we can get the report in February next year. So this is the latest report from the national surveillance. We had the vancomycin resistant 10% in Enterococcus faecium, 2% in Enterococcus faecalis, and also increased resistance rate in Acinetobacter babooni. This is all the human pathogens bacteria, and this is vancomycin resistance. How how scary of this, the last resort of this antibiotics against the gram-negative. And also we have the imipenem and parapenem resistance, 7.7% is Pseudomonas aeruginosa, and but for against piperacillin and tazobactam is decreased resistance. Thank God for this report. So this is the current scenario in Malaysia, and we have some from 2014 to 2019. You can see here the ampicillin is never decreased but always increased resistance. Maybe 85% in 2015, a little bit down to 20 in the 2015, and it's increased to 90% in the 2019. This is percentage of resistance. Gentamicin and vancomycin, and the linezolid. This is the trend for the against the Enterococcus faecium. For the different antibiotics against the Acinetobacter baumannii, as we can see here, is the increase of the resistance of antibiotics among the Acinetobacter baumannii, especially in the majority of this isolate recover from the patient in the medical intensive care, surgical and ONG orthopedics department. This is all the samples coming from against different antibiotics from the 2014 to the 2019. Especially you can see there is for the 2019, the green color one, for these particular things. And for the Pseudomonas aeruginosa, so increased resistance was noted for all antibiotic tested in 2019 in comparison with the 2018. We're comparing the green color and blue color, light blue color bar is all increasing. It's from the for the imipenem and meropenem increase from decrease, was decreased, but it decreased from the increase from the 5.2 to 7.7%. Okay. This one for the Salmonella typhi, that one is the decreased antibiotic resistance, especially for these 5 different antibiotics. Ampicillins from the 15% to about 4%, and others antibiotics. Chloramphenicol from 8% to 2.7%. Right. I search in the literature for especially for the Indonesia research. They have reported by Amanda et al. 2020 in the Journal of Microbiology, Immunology Infection, that said that 44% of Streptococcus pneumonia has been isolated from patient with commonly acquired, and is a resistance to the tetracycline. Another particular research by Sugali and all in Journal of Antimicrobial Chemotherapy is 2017. They carry out the research based on the patient-based surveillance of AMR in E. coli and Klebsiella pneumonia that causing urinary tract infection. This is show the resistance to the commonly available empirical treatment option is very high. So they said that smart AMR surveillance strategies are needed to inform policymaker and to guide intervention for this particular bacteria. Despite of this is a plus one Actabori 2019. They said is among the carry out the research among the infant until 18 months old. despite the low community consumption rate, the overuse antibiotics in URTI and non-bloody diarrhea in their setting represent a major opportunity for antimicrobial stewardship, particularly in the early life. So this is some alarm notes that should be taken by appropriate people to see what's happening here.
Pardon me, Prof. Nola.
Yes.
Your time is 15 minutes left, Prof.
It's like
15 minutes.
Oh, another 10 minutes. All right. Okay. Yes.
15.
15. All right.
Yes.
Thank you.
Thank you, Prof.
Yeah. So this is some more what you call it? Some more research being carried out in Indonesia 2018 for the ESBL, and then the resistance rates in the Salmonella typhi and Salmonella paratyphi very low as well. Similar result in Malaysia. Yeah. Right, so I think we come to the last part of my presentation on the research on antimicrobial agent. You know, by knowing antimicrobial resistance taking place, to understand the behavior of the bacteria, which bacteria that are resistant to which antibiotics, and the balance of the cases. So actually we can we can narrow down the research in this to find antimicrobial agents, in that sense that to combat this resistance, how to do the research. This is how should be the ideal situation. Actually, I'm talking about my presentation, but actually what I did is the other way around. Yeah, I'm maybe it's not in the ideal situation. What I did is I find the antimicrobial agent. I start my research in antimicrobial agent for the 10 years first. And after that, only I just realized that I should know how the antimicrobial resistance working. First, what the bacteria is resistant to, what antibiotic that, what kind of compounds, active compound that I should try, I should see, I should explore, I should find what kind of compound, bioactive compound that can be used to kill the bacteria. You see, so it's okay. It's never too late. Yeah, never too late. It's always something that learning process. You know, even though we think that we are good in research, but sometimes we have to slow down and say, look, I have to see the other way around first. Something like that. So this is all life. Never too late to know everything. Never too late to say that, oh, I'm not so correct to do the research. Something like that. Yeah. So this is something that is just explore journey, exploring new things. So the antimicrobial agent that we done in our labs is looking at this compound, the bioactive compound from microbe itself. You use the microbe to kill another microbe. That's what we call it, endophytic microbes that isolating from plant. One part, this is the first part, and another part we use the plant itself. The medicinal traditional use plant that being used by native people, maybe, but used by our great grandmother, great grandfather. They use that to cure diarrhea. They use that to cure tuberculosis, something like that, and we use that plant. So the plants, we use the plant itself, and we isolating the bacteria, the microbes from the plant in order to produce the bioactive compound. So two different approach, because if you're using the plant, how much you can harvest? 100 kilos? Tongkat ali is lost now. 1,000 kilos is lost now. But if you're the bacteria that coming from tongkat ali, for instance, we can always reproduce because they are bacteria. They are easy to grow in the lab. So this is how we see the approach. This is coming when I start meeting one of the father of endophyte in one of the conference, Prof. Gary Strober. So he give the ideas. I mean, I am very young at that time, 2001, I think, not so young maybe, but it's just started my journey, my research. So meeting him, so incredibly talk about these things. So I went to his lab in the Montana State University and starting looking for the endophyte. Right, so we use the plant, we start with the native medicinal plants first and isolating the bacteria from the normally from the stem, from the batang, the stem of the bacteria or the roots, we surface sterilization, we culture the bacteria, and we targeting mainly for the actinobacteria such as streptomyces, that the 70% of the antibiotic nowadays is coming from the streptomyces. So we identify the streptomyces and then we extracting the metabolites from them. Getting the pure compound, screening the antimicrobial activity. And that is one part. Another part is the plant itself. The plant itself, we're doing the primary screening. If they're good activity, so we're starting to do the extraction using the organic solvent as well as to do the secondary screening. All right, so this is first paper that produced together with Gary Strober that we started in 2000. This is paper in 2007. Yeah, the start experiment is 2005, isolating the different streptomyces endophytic meaning from the plants, the plants, and getting the isolates. In our lab now we have more than nearly maybe 200-300 isolate of streptomyces to start to do the screening and of course have the different activity. So we have one of them is characterization of this particular isolate. SUK is stand for the strain University Kebangsaan that have this antimicrobial activity, one of my master student. And we have these particular plants that been used traditionally in Malaysia for the after birth treatment, Quercus infectaria that can be used as against oral pathogens. Another thing is this, we use as well different technique, nanoparticle size of the chitosan, for instance, that have a drug delivery system that can be used as an antibacterial effect. So we have a collaboration with the pharmacy department to do this project. And yes, we have this activity against Acinetobacter babuini. We have screened about 60 isolates from the endophytic streptomyces, and the 14 isolates have activity against the Acinetobacter babuini when we starting to do the extraction and then find this active compound. What's the active compound that been in this endophytic streptomyces able to kill the Acinetobacter babuini. We have this research as well together with the Faculty of Medicine that producing try to look for the using of the imipenem. That's is one of the drug is not really good or is good at the moment, but when we combine with another drug, trigacycline for instance, it can be good potential to use against carbapenem resistant Acinetobacter. This is one of these research that been carried out in one of my PhD student 2015. The paper produced for the anti-malaria activity against this streptomyces, producing by the streptomyces SUK10. We produced chemical compound, the bioactive compound, is namely gunsidine W, from this particular isolate that we can use to kill the Plasmodium Plasmodium falciparum for the malaria parasite. Also for this MRSA from other isolate SUK25 that produce the cyclopentaphenyl propyl and chloramphenicol as well to be used to kill the MRSA. Cancidin W together with the other previous paper for the anti-malaria activity. And we have another, this is from the MRSA, SUK25, another compound. So you can see there is a lot of different chemical compound, bioactive compound that can be produced by Streptomyces in the phytic. We started from the scratch, isolating from the plant and then producing them, and then one of them, many of them are novel isolate that produce a novel compound. Like one of them is the kebangsaaniensis, Streptomyces kebangsaaniensis that we name after UKM that produce the phenazine from the new antibiotic. This is in BM, so everybody is open. This can be read 2019. All right, and the last one, we produce this paper for using honey, raw Malaysian stingless bee honey that been used to kill the gram-negative and gram-positive bacteria. I think this all right. This is the last slide, and thank you very much from all of us in Novel Antibiotic Research Group in UKM. Thank you very much.
Thank you very much, Prof. Nora. What a wonderful and enlightened information that you give to us this morning, that a collaborative network is necessary to against this antimicrobial resistance issue, and also to see your research, so many publications that you've been made to find another alternative antimicrobial therapy, which maybe later I want to ask you something about. Is there any industrial in Malaysia try to seek this new compound to produce new antimicrobial drugs, something like that? But we will discuss it later together with other questions which already pop up in the chat room. Thank you very much for Prof. Nora, and please stay in this e-seminar. We will proceed to second speaker, Dr. Anis Karuniawati, medical doctor, PhD, consultant and clinical microbiologist from Microbiology Department, Faculty of Medicine, Universitas Indonesia. Dr. Anis is my teacher until now, and also my role model here in our department, of course. And short curriculum vitae, as I can read here, I also received outstanding CV, which we here try to pursue this kind of CV. Dr. Anis completed medical doctor from Faculty of Medicine, Universitas Indonesia in 1990, followed by clinical microbiology specialist in 2001. Furthermore, Dr. Anis completed doctoral degree from University of Hohenheim, German, in 2006. During her professional career, Dr. Anis also received many recognitions in international and national level. And nowadays, aside of her activity as lecturer and second vice dean of Faculty of Medicine, Universitas Indonesia, Dr. Anis also secretary of National Committee of Antimicrobial Resistance Controlling Program, Ministry of Health, Republic Indonesia, member of board of Indonesian Society of Infection Control, or Perdalin, and member of Antibiotic Resistance Controlling Program team in Cipto Mangunkusumo Hospital, Jakarta. Dr. Anis also involved in many collaborative research projects The latest one may be together with Indohun, Indonesia One Health University Network, and ongoing research with Erasmus University Rotterdam, focusing in antibacterial resistance. Without further ado, I would like to welcome Dr. Anis to deliver the presentation entitled An Eco-Health Approach to Develop Strategies to Control Antimicrobial Resistance in Human, Animal, and Environmental Health in Indonesia. Dr. Anis, 60 minutes time is yours now.
Okay, so thank you very much, Dr. Fitri, for your very nice introduction about myself. And thank you also for Professor Nora. You have already presented a very comprehensive subjects in antimicrobial resistance, and also for your share about your research. I hope it will your research products also produce also alternative for our antibiotics. As we know that, and already explained by Professor Nora, that the problem in antimicrobial resistance is it's actually a very big problem. It is from upstream to the downstream, and from the production to the user. Yeah, so all aspect, all component of these actually has to be involved in controlling the antimicrobial resistant problem in the world. So we know that AMR is the global problem, not only here in Indonesia, in Malaysia, in Asia, but also in the whole world. Even from the literature said that in the pole, it is also isolated the AMR bacteria. Yeah, so we have to face this, and together we need to collaborate to overcome the problem. In this session, I want to share our research. Actually, this is a public health research about the eco-health approach in controlling antimicrobial resistance in human, animal, and environmental health in Indonesia. These are the names of the researchers. So we are from very different expertise, from the socioeconomic, community engagement, veterinary, from public health, and me myself from the clinical microbiologist, from the epidemiologist, and Winda, Ibu Winda is actually the principal investigator at that time. And we collaborate with, this is the NGO maybe, the CIFAS, or Center for Indonesian Veterinary Analytical Studies. Yeah, so it is actually already a few years ago. So the research was done in 2014 until 16. But for me, myself, it is a very good memory, because we come together, work in the grassroots, and we know exactly what actually the problem we face in the community. So as Professor Nora has already explained about the complexity of the AMR problem, this is a multi-dimensional, multifactorial problem which involves various socio-economical levels of the community, from farmers, public and private industries, consumer to decision makers at local, regional, and national levels. Yeah, so from industry, I have to tell you also that the pharmacy, the big pharmacy, until now they don't have any interest anymore to produce a new antibiotic. So actually, in the last 20 years, there is no new antibiotics. We have only the modified antibiotic. The combination was new, but actually it is not the new antibiotic molecules. Why? Because the production need much cost and long time from the first phase until the fourth clinical phase. And then the use of the antibiotic, as we know, in patients only for 1 week, 2 weeks. So for them, it is much benefit to produce drugs like anti-diabetic, anti-hypertensive, because the patient will use this for a long life. Yeah, so that's why it is our problem now, how we use the available antibiotic prudently, rationally. Disciplinary approach and wide range of stakeholders must be involved to solve this problem. And the integration of veterinary science and human public health, epidemiology, and socioeconomics is very important, are very important elements to develop and recommend solutions and strategies. So eco-health is actually the same, has the same meaning with the way we use this eco-health. So the definition of eco-health is that this is the field examines the complex relationship among human, animals, and environment, and how this relationship affect the health of each of these domains. Yeah, so this is exactly the same meaning as One Health, but because this research is funded by the IDRC, which is the institution in Canada, and so the government of Canada prefer to use health instead of One Health. So that's why we use words eco-health in this research. So the goal of the research is to explore, develop, and assess the effectiveness of a strategy to the proper use of antimicrobial in humans and animals to control antimicrobial resistance in Indonesia. And we have 8 objectives, but I compiled it as a 5 objective for this presentation. The first is to understand the regulation and accessibility of antibiotics in animal health and human medical practice, and then to assess the knowledge, attitude, practice of medical doctors and antibiotics usage in health facilities, and then to increase local participation in antibiotic resistant control efforts. And the fourth is to facilitate better understanding on antibiotic use and accessibility in layer chicken, yeah, or ayam petelur, and swine farms, and develop potential intervention strategies for antimicrobial resistant prevention. And the last one is a survey on antibiotic susceptibility of E. coli in human, animal, and environment. So for the objectives 4, why is it in the layer chicken and swine farms? Because these both livestock use much antibiotic, yeah, rather than, for example, for the cows and also chicken. What you call, I don't know what is in English, ayam potong, yeah. So ayam petelur and ayam potong. And so this both livestock use much antibiotic. Actually, in for example, in cows, they use also antibiotic, but not so less than hormone. Yeah, so that's why we focus on these 2 farms. We did this study in Central Java, in the 3 district area, Klaten, Sukoharjo, and Karanganyar. So it is, of course, not easy for us because the office of the headquarters of CIFAS is in Bogor, and the researchers come from different area. So we are from Jakarta, from Bali, from Semarang, also from Jogja. Yeah, and then during this time, so maybe every 2 weeks I have to fly to this place to do the research. And the period of the field study is between February until November 2014. Yeah, by plane, it takes around 1 hour from Jakarta to Solo first, or Surakarta, and then we go to this area. So it is not far away from Solo because it is in the near, so this is a neighborhood of Solo. For the research preparation, we had meetings and then pre-surveys, and also technical coordination in livestock services of the Central Java province, and also the public health office in the district level. And then also we do the field staff training and questionnaires trial, not only to the health workers, but also to the community and the farmers. Yeah, because we have it's different questionnaires for them. Yeah, so we proceed to the first objective, to understand the regulation and accessibility of antibiotics in animal health and human medical practice. This is actually the desk study. We do the data, we collect the data, all the relevant information, document, all the act, undang-undang, yeah, and also the decree, peraturan menteri, and also some guidelines. So we gather all of those data and do the systematic review and also analyze the gap rise in Indonesia. So this is the result about the supply chain and distribution of antibiotic and human health sectors. Yeah, when the antibiotic was produced from the local industry or imported from the international pharmacies, then of course there is a procedure for the license or registration to be sold in Indonesia. And then usually it is distributed by the medical representative, and it should be only to the pharmacies or hospital, but in the reality, we know that they also sell the antibiotic to the market and also to what we call the toko obat. Yeah, and we have here Professor Nora, what we call pasar market in Pramuka Street. There are many apothek, and some of them has the license, but some of them also don't have any license. Yeah, but I hope everything now is becoming better and better, of course. And also drugstore, yeah, and it will be bought by the public or the patient, yeah. And this is the system mapping of the antibiotic for human health. Yeah, so as I told you, from the producer or the importer, and they go to the pharmaceutical wholesalers, or we call it as pedagang besar farmasi, PBF, yeah, in Indonesian language. And all, of course, it is monitored by the BPOM, Dirjen Binfar. This is the Directorate General of Pharmaceutical and Medical Devices. This is under Ministry of Health, and BPOM, or the National Agency of Drug and Food Control, so Indonesian FDA. The Indonesian FDA, the BPOM, will give the registration, of course, after they do all the evaluation of the drugs. And then after that, they got the registration number, and they can sell it in the market. And hospital will get this, and also health centers and pharmacies. And this is the illegal way, of course. Drugstore will also get this from the PBF, or the pharmaceutical wholesalers. And all the permission of pharmacies in the hospital, health center, and outside hospital, pharmacies outside hospital, got the permission from the province health office. And every year, no, I'm not sure about that, but the monitoring system, they have to monitor them using, of course, the form, the legal form. They will check whether the drugs that used to be prescribed, it is really sold by prescribing or not. Yeah, so, but of course there are many drugs that have to be prescribed, not only antibiotic. So only antibiotic is only one of them. So sometimes, or most of the time actually, they don't really monitor how the pharmacy sell the antibiotics. And then also doctors, yeah, then do the prescription and to the consumers. Yeah. And this is all the association that they are users, but actually they produce the guidelines how to use this antibiotic. So in our program now, in AMR control in the national level, we always collaborate with this association, because they produce the guideline, and we hope that also they will monitor their members. Yeah? And how about in the animal health sector? The problem in animal health sector is so more what we call free, because they don't have pharmacies. There is no apothec for animal drugs. Yeah. And usually from the drug distributor, importer, it is directly the technical representative of each pharmacy will sell this antibiotic directly to the livestock services, to the veterinarian, or to the pet shop, animal drugstore, and drug mart. We know that all the antibiotic used for animals should be different with the one we use in the human health sector. Yeah, but in the reality, it is not like that. So some of the drugs are actually also the drug for human. Yeah. So this is what happened in the animal health sector, and also for the AGP, or antibiotic, which is used as the growth promoter and mixed in the food, or of the feed of the animals. Yeah. And actually, there is already an act, undang-undang, in 2009, which to melarang itu apa ya? So the yeah, so it is not allowed to use ATP in the feed, but it is not done. It is not implemented until there is a decree from the Ministry of Agriculture in 2018, January 2018. Yeah, so it needs 9 years from the act to the regulation. And from that time, since 2018, they try to implement this, yeah, so the antibiotic cannot be used as the growth promoter. And Professor Nora has already also explained about the colistin. And 2018, colistin is still used. But then in 2019, we discussed many times to make the regulation about colistin. And I hope I have not yet checked, is there already a regulation about this? But all the farmer already informed that they cannot use colistin anymore for their poultry or livestock. Yeah, so this is the system mapping in the animal for the antibiotic use. So from the distributor, it is directly to the drug depot, and then hospital and also drugstore. So no pharmacies here. Yeah, so it is, I don't know how they monitor this, but yes, there is a monitoring system, but I don't think it is like in the human sector. Yeah. So this will not influence the permission to open to give the services in the hospital. Yeah. So there is one thing that I have not explained is about the black market. Yeah, this is something that actually we don't know really, because sometimes from the importer, of course, there is some antibiotic which is not sold every year, or maybe already expired. Where are they? Yeah, so we assume because in one on two farms, we found this kind of antibiotic, so the expired antibiotic. So, and some people said that they got it with the cheap price with a low price from somewhere else, and they don't want to mention it. Yeah. So Indonesia is very big countries, and it is very difficult to control everything like this. Yeah. And about the gap analysis, so I show you only some of them, but it is the important one. The current situation, there is an improper prescription of antibiotics. It is actually in 2014. We try to make it better and better by doing the education or the workshop for all hospital and doctors. But you know that, again, Indonesia is very big. Until now, it is actually not 100% doctors know about this or aware about the AMR problem. Yeah, so we have produced the like stewardship guideline, antibiotic stewardship guideline, and also all the regulation that the theme of AMR control in the hospital is one of the component in to get the hospital accreditation. Yeah, but so they have already, each hospital has their team for what we call it antimicrobial resistant control team. Yeah, but whether they do it properly, we have to monitor every year. Yeah, so the other thing is also improper consumption of antibiotics by patients. Yeah, so that's why we said to the doctors that they have to give or to educate the patient every time they prescribe antibiotic. And also we have to educate the community, the patients. They have also to ask the doctors every time they got the antibiotic, then they have to ask the doctor, so what is your diagnosis, and why I have to take antibiotic for this diagnosis. Yeah, so this is very important question to make the doctors also to remind the doctors to educate them. And then the third one is that antibiotics can be purchased without prescription. And for this, we collaborate, of course, with the Indonesian Associate and Indonesian Pharmacy Association, and they do also the same thing, educate all the pharmacies, the assistant pharmacies, that they have to comply to the regulation. And then how about in animal sector? The current situation and still until now in the most part of Indonesia is excessive use of antibiotics on farm. And they need this they said that it is to prevent the infection. And that's why our colleagues from the Ministry of Agriculture now conducted many workshops for the biosafety of the poultry and also livestock. Yeah, because the hygiene is the most important one to prevent the infection in livestock. And then the second one is the very important things is also that the animals sold or slaughtered without considering antibiotic withdrawal time. Yeah, so there is a certain time that they have to comply between the putting the antibiotic to the animal until when the time to slaughter. Yeah, and they have to comply to this time, to this period of time. Yeah, so with education also. Yeah, the second one is to assess the knowledge, attitude, and practice of medical doctors and antibiotic usage in health facilities. So this, in this part, we did it in the 3 districts, yeah, in the Sukoharjo, Klaten, and Karanganyar in Central Java Province. And we involved at that time 40 puskesmas or primary health care center in the sub-districts levels, and also 14 hospitals. This is district hospitals, so type class, we call it as, categorize it as a class C and D. And then we do structured interview using the structured questionnaires. And then this is the respondents. So most of them are so more female than male, and then in this age, and so all of them are general practitioner with the experience of work more than 9 years mostly, and duties duration in this health facilities more than 5 years. And this is their knowledge wherein this is in, sorry, it is in primary health care, yeah, and the knowledge about antibiotic use is actually not so good. Yeah, because most are moderate, so not high, even though they are doctors actually. And then also in the hospital is much better than in primary healthcare. And then in the practices, usually they prescribe antibiotics, so most of the time only once a day, regardless what kind of antibiotic is that. It is because the availability or the stock of the antibiotic, it is very depends on the stocks of the antibiotic in that particular puskesmas. Yeah. And then about so this is why in upper respiratory syndrome and non-specific diarrhea, in the next slide, I will give you also the data from Ministry of Health, because these two disease or these two diagnoses as a parameter for the rational use of medicine, that both has so not use antibiotic have, so antibiotic should not be prescribed for these two kind of diagnostic, but in the reality they give it in the 65%, and also in the non-specific diarrhea sometimes they give it, but most of the time not really. Yeah, so this is data from the Ministry of Health from 2010 to 2006. So in their parameter for diarrhea non-specific, because it is caused by viruses, the target is 8%. But in this time, in the this period of time, it is always more than 40%, even though they have already educated the health workers there, the doctors as well. And for acute respiratory infection, non-pneumonia, it is also mostly caused by viruses, and the target is 20%, but it is always 40% during this year. Yeah, so it is actually very important. Unfortunately, after 2016, I don't know why, Ministry of Health did not do this kind of monitoring anymore. So I don't have the data after 16. This is the antibiotic. These are the antibiotic they use in the primary healthcare. Mostly are, of course, the oral antibiotic and also the hospital. Some of them are parenteral antibiotic. And this is the mostly they use amoxicillin, cefadroxil, ciprofloxacin, metronidazole, cefixime, levo, and erythromycin. So it is still okay. I mean, they don't use the reserve one. They don't use the cephalosporin too much. Yeah, but they do use the levo, the fluoroquinolone. Yeah, so this is the assessment for the facility of this both puskesmas and also our primary healthcare and the hospital. First is about the use of antimicrobial, the stocking system, that they got these drugs and also antibiotic from the public health offices. Yeah, so the distribution is from them, from the health services at district level monthly. So they got from directly from the external pharmacy, but with the approval from the public health office. And then, so as I told you that the usage or the prescription is very much depend on the stock provided. So that's why sometimes they give it only once a day for 3 days, or maybe sometimes 2 days. So without knowing how this antibiotic actually work. Yeah. And then they have to report everything, the use of the antibiotic to the health services. And about the education, they don't do it. properly. So when we ask about the how the doctors educate when they prescribe antibiotic, and they said they don't do it because they think that the patient can read themselves from the labels. Yeah, so both in the primary healthcare and also in the hospital. Yeah, so we try to explain about this because this is very important to explain it to the patients. So always the reason is too many patients, they don't have time to do it and so on. And then about the antimicrobial resistance, they don't have the specific program for this. They don't know or also they don't do the surveillance program. So there is no microbiology laboratory in their area. If they need, then they have to send it to nearest cities, which is Jogja and Solo. And of course, it takes time. Yeah, so from the recommendation, at that time, we said to or explain it also to the public health offices to do the regular capacity building for all the health officers, health workers about the AMU, antimicrobial use, and the AMR, and then also education about the prudent use of antibiotic as the key messages, and improvement of the regulation and monitoring system. Yeah, and then also the increasing the surveillance program for antibiotic resistance. The third one is to increase local participation in antibiotic resistant control efforts. This is the most interesting for me, yeah, because we really involved in this part with the grassroots, with the community. So at first we do the baseline assessment, problem identification, and reaching an agreement with the community because it is very hard to explain about resistant in bacteria, something abstract for them. The frequent asked question is, what happened if I take antibiotic? So actually there is nothing happened at this time. So that's why we have to explain them slowly and then clearly that this is for your next generation. So for your children and also for the environment. And then after that, we do the training for the capacity building, running the program and mentoring, and then monitoring, evaluation, and program adjustment. So we collaborate with 93 health volunteers in the community, and they were trained to become bijak antibiotic cadres. So most of them are actually health cadres, kader-kader kesehatan for tuberculosis. Yeah, and so they are very keen to know more and more about the antimicrobial resistance. So I like them very much, really. And these cadres come from 4 pilot villages and 2 observer villages in these 3 districts. And these cadres are a group of local people and the health volunteers, and also they usually take 2 or 3 people from each sub villages, yeah, dari RW, yeah, from we call it as rukun warga, Professor Nora. This is the smallest one, the smallest unit in the community. We call as RT or rukun tetangga. Yes, usually it is in one street. Consists of 50 until 60 families, and then some rukun tetangga is unite in the rukun warga, and this is what we call as sub village. And these cadres are selected based on their willingness to increase community health level. and regardless gender, age, and education background. So the first part, we do the baseline assessment. We give understanding about what is AMR problem. And then the second one, we do the second part, we do the all the training using some method, role play, simulation, group discussion, and class presentation. And at that time, the most interesting one, we ask them to bring their drugs, which is stored in their house. And then they have to tell us what is it, for what is it, and how they got it. And they don't know actually which one is the antibiotic. So this is another thing that is very difficult. How they know that it is antibiotic? Because when every time when they go to the pharmacies and they said that I got flu, I have sore throat, I need drugs, and the apotheker, the pharmacy will give it, and they don't know which is it is actually analgesic or antibiotic. Yeah, and there is no explanation more about the drugs from the pharmacies. And then we did the evaluation. So how they understand the problem and what can they do for their surrounding for this. They were very, very active. And their job is to educate the community. And every time they do this, they write it down in the logbook, what we call it logbook, what they do and with whom they speak about antibiotic, even though they just speak with their husband, for example, they have to write it down. And then after the evaluation, they give this sign and then put it in their house that this is a cadre for bijak antibiotic and the name of the cadre. Yeah, so this is the key messages. So because okay, I told you about the farmers. So the other reason that we choose that place is that more than 60% of the community are farmers. That's why actually some of the cadres are also farmer. They have their own farm in their house. So behind the house uh, in the surrounding of the house. Yeah, so that's why we do both the key messages, what we call bijak, with two different meanings. Yeah, so beli, it's buy with the prescription, and then I, it is in Indonesia, ikuti, follow the rule of antibiotic usage. J is jeli dan berani, aware and be brave to ask doctors. Awasi, caring for antibiotics usage in the family, and consult with the doctor. K. For the farmers, it is B, give for treatment, so not for prevention. And then ikuti is follow the rule of the antibiotic usage. And then J, jaga masa henti obat, aware for withdrawal time. And then A is awasi, caring for antibiotics usage in farm. And then consultation, consult with veterinarian. Yeah. So we give all the tools for this. I will show you later. So this
Dr. Anis,
yeah.
pardon though, 20 minutes left.
Okay, thank you. Yeah, so of course they are not paid for this. The cadre are not paid, but because they are really volunteers that very smart also for their level, and they proud of themselves that they know from they have more knowledge than the others. So that is the benefit of them. So I hope they still do it until now. Yeah, so the recommendation for this part is replicating this model on the village level. So and then of course they need the technical support, so like mentoring, evaluation, and program adjustment. Yeah, so the fourth objective is to facilitate better understanding on antibiotic use and accessibility in layer and pig farms and develop potential intervention strategies for antimicrobial resistant prevention. So we did it in the 40 layer chicken farms and then 40 swine farms in the same period of time. And then the respondent is farm owner. So some of them, the wife is the caterer and the husband is the farm owner, and then manager or worker responsible for animal health management and farm. And we use also structure questionnaire, and this is the characteristic of the respondent. So they are mostly are small scale farms, which is they have only less than 5,000 birds. And also in the swine farm, also the small scale farm mostly, and small scale means less than 100 pigs. And education, so mostly are lower than high school. So again, this is a challenge for us to give the good understanding for AMR problem. Yeah, most of them didn't have any veterinarian or veterinary technician. So they gave all the feed, the drugs by themselves. Yeah, how they got this antibiotic? So usually this is to give or not the antibiotic is decided by the farms themselves. And then they got it from the poultry shops and also from the technical services of drug companies. And this is all the drugs, or the antibiotics they have. And mostly the purpose of the antibiotic is for treatment, and the other one is for prevention. And this is the accessibility of the drugs. And if we try to calculate how much they spend their money for the antibiotic, and they said so most in the maximum is only 1.3% of the total production cost. So it is actually not really much. This is of course the drugs that in the what we call as a drugs. So we don't know how about the mixed drugs in the feed because it cannot be identified. And if we ask them what is the ingredients or the content of the food, the feed, they don't know. They don't really know. Yeah, and this is the antibiotic used in pig farms. Yeah, and also the purposes is for treatment. Yeah, so the conclusion of this part is that the many antibiotic used in layer farms are broad spectrum and combination. As you see here, this is a combination, and penicillin and streptomycin, for example, and also in the layer, penicillin and strepto, amoxicillin and colistin. Yeah, and then there is no indication of antimicrobial resistance from the clinical science. Yeah, and then it is the access is very open, so there is no monitoring system also in that how they got the antibiotic. So the last one is a survey on antibiotic susceptibility of E. coli in human, animal, and environment. Yeah, so we try to collect the specimen from some places, so not all part of the districts, And then we try to choose the villages as a representative of this part of study. And we do the collection in the pig and layer farms, and also the farmers and their family, and the wastewater as the environment of the farms. Yeah, so this is the first district. We choose 3 villages, and then each of village only 3 farms. So samples, pigs is from rectal swab, layer chicken from cloacal swab, and human from stools, and then the environment is from wastewater. And this is the number of the samples. So it is a little bit different with the human. If human, then every individual of the farmers will be collected, and it is counted as one sample. But in the farms, there is pool. So one pools means taken from 10 pigs. Yeah, so the swab is from 10 swabs from 10 pigs, and then pull it together in one as a one sample, and then take the isolate the E. coli as a parameter, yeah, for the resistance. And we do this work in the 2 laboratories. One is Diagnosis Investigation Center, or BBFET in Wates. This is near Jogja. And the other one for human, we do the laboratory examination in Muardi Hospital in Solo. Yeah. And of course, we collaborate to do this in the same way. And we culture the swab and also the stool to Mekongki agar, and then identification for E. coli. In the human sample, Phytec2 is used from BIOMEDIKA, and then animal and environment samples is done manually. And then both the antibiotic susceptibility test is both use this diffusion, and this is the quality control. So for the internal quality control for antibiotic susceptibility test, both laboratory has to do 20 replicate of tests for each antibiotic. So this is the antibiotic we use for this. And this is the number of E. coli we got from all the samples. And the totally is 725. And this is the result. So this is only in the pig farms. Yeah, E. coli from pigs, from the rectal swab. This is from the wastewater. This is from the farm workers and the family of the farmers. Yeah. And the blue one is the susceptible, isolate, and the red one is resistant. Intermediate, and the green one is the resistant. And this is the antibiotic. We see here that the what do you call it? The pattern is almost the same among this group of isolates. Yeah, for example, this is ampicillin, and the question is actually why the cephalotin is there is an intermediate, because they don't use this. And also the chloramphenicol, there is an indication that some of the isolate is already resistant as well, even though they don't use chloramphenicol as drugs in the livestock. Yeah, so and this is ceftriaxone is still good, gentamicin also, and ciprofloxacin. Yeah, so but we see here that this is showing us the similar pattern. And also in the chicken farms, it is almost the same with the pig farm. And of course, this is only a phenotypic pattern. It will be much better if we can do the genotyping, but unfortunately, there is no more funding for this, and that's why we stop until this phenotypic characteristic only. So there is a conclusion. As conclusion, there is a similarities, and cephalotin is the first generation of cephalosporin. We use it only usually not for therapy. Much this is used more for the prophylaxis, and then maybe there is possibility that chloramphenicol is actually also being used in that livestock. And the recommendation is that the survey of this antibiotic susceptibility should be done periodically to evaluate the AMR control program. And we have to strengthen the hygiene practice and prudent use of antibiotic in human and livestock. So this is only, I just want to show you the products of this study, buku panduan or guidelines for the farmers. And also this is for the pig farm, and this is for layer chicken, and this is for cater. And also this is kind of what do you call flip chart or like a desk calendar. Yeah, so how they have, so the cater have to give or educate their friends, their family. So this is the one that they have to show to the friend, and this is what they have to explain. Also this one, we have to try, we have to explain them what kind of drugs is actually found in the drugstore. You have to watch this about the green cycle, red cycle, and blue cycle. What does it mean? This is restricted and this is free. This is restricted, but have to be careful to use it, and so on. And also we give them the to identify that this is antibiotic or not. Yeah, using so maybe with that cycle, if there is the red cycle, if there is a statement there that this should be prescribed by the doctor and should be taken until all of the drugs. So this is mostly are the characteristic of antibiotic. Yeah, this one they have to show them which one is the antibiotic and which are not antibiotic. So this is the team, and I'm sure that you know him, Professor Nora. This is the Professor Wiku, the chairman of Indohun, and we collaborate also with him very closely. And acknowledgement for IDRC, for APEA, and then also all the stakeholders in this study. Thank you very much. I'm sorry if I take the time more. Thank you, Dr. Fitri. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Anis. Actually, the time is still 6 minutes left for you.
Okay, it's okay, because it's already adhan.
Yeah, it's adhan now. Maybe in Prof. Nora place in Malaysia, it's, I don't know, 1 hour ahead from us. Yeah, I'm sorry, I a bit forgot about how is the time different between here and Malaysia.
In Malaysia now it's 12:43.
Oh, 12:43. Yeah, so you're 1 hour ahead from us, Prof. So we will continue to this discussion session for this e-seminar, which already several questions pop up on the chat room, and I already get the the brief copy of the questions. And there are 3 questions. Firstly, it will go directly to Prof. Nora. And first question is from Mewah Yudewi from EOCRU. The question is, what are the factors that may cause decrease of percentage of IMR? What are the factors that may cause decrease of percentage of IMR? Maybe from your data previously there in several years, their trend to the AMR level is decreased. So
Yes,
it's
yes.
wrong.
Yes, thank you for the questions. Yes, actually, it's a lot of things that we can do to decrease the AMR, the usage, decrease the antimicrobial resistance is to reduce the use of antibiotics. Actually, that's a main factor. But in order to do that, we need to have the people that understand. To prescribe, for instance, to prescribe the correct antibiotic, not to misuse, not to overuse of the antibiotics. Let's say some patients just simply ask the antibiotic for the flu, for the infection, flu infection, and of course, in the Europe, for instance, they have the ban of using the certain antibiotics in the agriculture. So it's one of the way to reduce the AMR. And then, of course, we need to have the global public awareness campaign, like Dr. Anis and the team doing a community to educate people. It's very, very good. I interested very much to do that, actually. Maybe for our next module, for our next coming student, we can do that, reach to the community level, to do the awareness program. And of course, another aspect also is to improve the healthcare system. So improve the healthcare system, improve the sanitation, so it's an infection diseases will be decreased. And of course, the need of the antibiotics will be decreased. And we'll use lesser and lesser antibiotics and can reduce the antimicrobial resistance. And another thing that I might be forgot to touch in my presentation just now is to promote a new or rapid diagnostic kits, for instance. So this can avoid to misdiagnosis. Some patient just go to see doctors, and maybe doctor is prescribe a lot of broad what you call it, broad antibiotics. It cover gram positive and gram negative at the same time. Sorry, broad spectrum. I just lost the word. Sorry. The spectrum of the antibiotics, and yet the patient is only infected by the gram negative, just for instance. So if we have the rapid diagnostic tools that can be used, we have a new project with the engineering people. They develop a new biosensor, which can detect this COVID-19, for instance, in a very short time. Instead of RT-PCR nowadays, it took maybe 6 hours to get that. But with the biosensor, it's very rapid. We can get the result in 20 minutes, for instance. So it's very important to get the rapid diagnostic tools. And the last one, I think we can promote the use of the vaccine other than antibiotic with the Clostridium difficile. For instance, we already have vaccine that develop, but of course, when you say the vaccine development, it is not a lot of money. Still ongoing process. So that kind of things. Thank you very much.
Thank you very much, Prof. Nora. And the second question is from Muhammad Helmi Aziz. He's a student in our clinical microbiology specialist. Does plasmid mediated resistance has a limit? How many? And how big is the plasmid mediated gene IMR can be encoded in a single bacteria? Is there, Prof. Is there a trade-in and trade-off mechanism for plasmid-mediated gene IMR, since bacteria has restrictive endonuclease? Oh, it's very basic.
Yeah.
So biomedical, Prof.
Yeah, it's an advance for me actually, because I never done the plasmid research per se. But as you know, the plasmid they have a self replicating, the self replicating system, that all the mechanisms can be found in the plasmid. So of course the AMR genes is carried on the plasmid. It can be transferred from one bacteria, even in the same species or different species, through the conjugation. So normally multiple, not only one genes, multi-drug resistant genes is carried by this plasmid. So it's moved from different plasmid or from to the chromosome. This can be moved. So from the recombination system. So from the we know that this resistant plasmid, the plasmid that carry the resistant genes conjugative, which is about 30 kilobase. The size is not so big, it's smaller, but even though it can be used the damaged by the restriction and the nucleus, for instance, but they already have self-replication elements. So the function of the resistant gene is still there. It's not cannot be harmed by the what you call it, the enzyme or whatsoever. And this to answer to trade in the trade off, you really need to do the research, deep research on that. I just cannot comment on that actually, because I never done the plasmid research yet. But it's really interesting to know that this to further up this research in order to understand. And some of the research, they said the curing the plasmid, they kill the plasmid itself before you have some compound, some chemical compound that can be taken orally to kill the plasmid itself. So it's can stop the antibiotic resistance. There are some, but it's still not approved by FDA yet. Okay.
Thank you very much, Prof. And then I think this is the last question for you from Asbar. Some assumptions say that some species, especially in mosquitoes, as factor that resistant to some fogging active substance, may become sensitive after some years termination or replacing that active substance. This is for example, and the question is in antibiotics resistance, this kind of phenomena can appear, and can we just do this strategy to reduce the IMR by replacing the drugs, or maybe terminate the drugs for certain time, something like that, Prof?
Yes, thank you. It's like for the fogging things, because we know that the resistant genes is in the DNA itself, and then the changes, the mutation can be easily taken out. I'm not sure how the current research to see the mutation taking place in the bacteria, in the plasmid itself, when exposed to those chemical, for instance. But I'm sure it can be happen actually easily, because the mutation, especially for the DNA mutation, just even for one single nucleotide, it can code for the different amino acid already, maybe. So it can be happen easily. So the strategy, that's what people are looking like to in the curing the plasmid and so forth. This is one of the strategy, I think, that can it is at the very molecular level. It's the application to the human host response can have to be considered as well. It might have some toxic effect. So that kind of things that need to be done, like first phase clinical trial, second phase clinical trial, and so forth. So the main important is prevention, I think, if we want to stop to reduce the spread of AMR. The prevention is better than cure, in that sense that the avoid to use the misuse or overuse of antibiotic, the global awareness campaign and so forth. It's the prevention can be play important role here. Yeah, thank you.
Thank you, Prof. Maybe Dr. Anis has some comments about this usage, maybe in the patient uh, scenario or something.
Yeah, so it is we know about the bacteria communication maybe. So this is also one hypothesis that in our colon there are so many bacteria that they can what you call so the movement of the plasmid can be happen also there, and also the selective pressure. It is also very important that because this antibiotic is actually not directly only kill the pathogen, but also the other bacteria which are susceptible to this particular antibiotic. So, and we know that actually the number of bacteria cell in the human is more than the number of the human cells itself. If I'm not wrong, Professor Nora, I have read about that the bacteria cell is so many in our body, so in human beings. So we have to be aware of that if we use antibiotic, it will also kill all our friends.
Our friends. The bacteria is now our friends. Okay. In a certain way. I will continue for the next questions is directed to Dr. Anis. It's from Rizka Aryani.
Yes.
She said that in Indonesia, we use azithromycin as one of therapy for COVID-19. I think this is quite new. As we know, COVID-19 is virus and not use antibiotics as main therapy. How is azithromycin work for COVID-19? Can it contribute for antimicrobial resistance of azithromycin?
Yeah. So it is not only Indonesia use azithromycin for COVID. Yeah. So this is the guideline is also the international guideline said also this. So we use azithromycin and also the chloroquine. Yeah, the anti-malaria. Yeah. So the answer is that so azithromycin in this matter has also the antivirus effect. So this is the new knowledge that I also got in this pandemic time. Yeah, so that's why this is the reason why even though we actually the knowledge about COVID is still on progress, it's still developing. So every time can be changed. Yeah, but right now we believe that azithromycin and also chloroquine have the good effect in killing or the eradicating the virus. Yeah. It will contribute, yes, of course, because azithromycin is a very good drugs. We use it for children also. Yeah, it's safe, and then also that we can give it only once a day, or maybe only one time therapy. And it works very good, but so this drugs is also easy to be so the bacteria is easy to be resistant to this drug. Yeah, so we have to be careful, of course, and we also have to understand that in the COVID patient there are some stages, no, some clinical performance. So there is no symptom and mild and symptom and also severe. The mild one, it doesn't need any antibiotic, also the azithromycin. And usually we use it for the moderate and the severe one. So this is my question, my answer.
Okay, thank you very much, Doc. Continue to the second question from Muhammad Helmi. I think he got insight from your previous study, Doc. Since that One Health approach involving human, animal, and their shared environment, how often should we screen to perform surveillance to detect emergence of IMR in environment? What kind of samples that should we take or use to evaluate the emergence of IMR in environment? Do we have data of IMR from environment? And the second one is why E. coli is used as a bacteria of choice in this study? Why don't use another bacteria?
Yeah. So in environment, there is no certain time to do the surveillance. Yeah, but there is no obligation also. But some what you call research center do this, and what I know is the Finlandia do this many things about the environment, AMR in environment. They observed that the AMR bacteria come from hospitals to the what do you call sungai river. Yeah. So if they don't do the good treatment for this wastewater, then the AMR bacteria, the resistant bacteria, can go to so far away, many kilometers from the hospital. Yeah, so they use this. The study for AMR in the environment is not done periodically. Yeah, there is no regulation for that. Also, the WHO right now only ask the countries to do the surveillance for AMR in human health, animal health, and also in fishery. Only these three that they have to do it. They have to report to the WHO yearly, but not from the environment. And how we do it usually, most of the study do the survey or the study of AMR in the environment is from the river and from the wastewater. That's all I think. And also maybe from food, yeah, from what we have done also survey on es batu itu apa ya?
Ice cube. Ice cube.
Not only cube, not only cube, because there is also ice to make the drink bottles cold. So you know the big box brick of ice. Yeah. So because it come from, for example, in Jakarta, they produce these ice cubes from the river Kalimalang. You know. But then this will be filtered, yeah, filtered. There is two ways, two kind of filter type filtering. One, it is for this ice to cool the drink, yeah. So it is not for drink, but to make it cool, yeah. But be careful that in the street they use also for drink, right?
Yeah.
Be careful. So don't drink any cold drink from teh bottle in the plastic, you know. So many children take this. And the other one filtered for the ice cube. This is good. sterile. But the other ice, it is very so it contains still contain bacteria and also the resistant one. So they do also this periodically and usually done by the BPOM, the deputy for food. Yeah, they have both food and drugs, and this is the institution names the intelijen pangan gitulah ya, the intelligence for food. Yeah, so the method is the same like what we do in daily, identifying the E. coli using biochemical tests, and then also the antibiotic susceptibility test based on CLSI standard. So I hope I answer the question.
Yeah, thank you, Doc. So, Prof. Nora.
No.
The E. coli.
So E. coli, so the one thing is that we use this as the parameter, like ESBL Enterobacteriaceae. So we usually compare this E. coli, ESBL producing E. coli, and also other Enterobacteriaceae producing, ESBL producing Enterobacteriaceae. This is the first one as the parameter. And then the second one, E. coli, is the easiest bacteria to identify, and usually it is very common to find it in as a flora, normal flora in the stool. Yeah, so I don't know, maybe that is the reason, but it is yes that we use most of the country usually use E. coli as the parameter. So maybe because also this is the indicator for like water. Yeah, if we do the microbiology examination for water, we count also coliform and E. coli. Yeah, so this is the parameter of the fecal contamination. I don't know. Is there any other reason for this, Professor Nora? Do you know?
Yes, I think that this is the E. coli always is the model of the indicator, for the many bacteria, because of course we have the full sequence, the characteristic has been known by details for the E. coli. As a model.
Yeah, thank you.
Yeah.
Okay.
Thank you, Doc. Thank you, Prof. Nora. And I think this is the last question for this seminar pointed to Dr. Anis from Ageng Wiyarno, our student in Master Program in Biomedical Sciences. When we detect superbugs in the pig or chicken farms, what are containment measures or strategies can be done to prevent the spread of the bacteria? Should we also trace the transmission to the people who consume products from the farm?
Yeah, so we don't have any guideline for this right now. Also in the hospital, for example, we have the infection prevention and control team in the hospital. And if we find someone with infection of AMR bacteria, then we do the what we call the practice is the using the precaution, contact precaution. Usually, if there is a patient with MRSA, methicillin-resistant Staphylococcus aureus, or maybe with carbapenem resistant or ESBL, then we have to do the contact precaution. So there is some step for that. And we have it in the human health, but we don't have it in the animal health. So there is no procedure how to contain, but the important thing is only the hygiene. Yeah, to practice all the hygiene procedure. So that's what I can explain. So there is actually no certain or specific procedure for that. Thank you.
Does this in contact precaution here is including tracing too, doctor?
Yeah, ideally, yes, we have to do tracing like in the hospital. What is or which is the source?
Yeah.
But then the question, who will pay for this tracing? Yeah, because the tracing in the bacteria is not only the phenotypic, right? We have to do genotypically.
Yeah. Okay.
Yeah, thank you.
Thank you, Doc. How about in Prof. Nora, in Malaysia? Is there any strategies can be shared here?
What
the strategies, yeah, for example, like Dr. Anis answered before, that the contact precautions here are only available right now only in human environment, only in the patient's environment. Is there any, I don't know, legal aspect maybe in Malaysia already available? That
No,
we should,
not yet.
not yet also.
Not yet also, yeah. We still, because the limitation of the funding, to do all these things need the funding, and very limited funding at the moment with this currently pandemic. The fund is very affected badly actually, for doing this kind of research. But we always try to get this. Once they get the funding, it can be done, inshallah.
We keep still optimistic, Prof. and Doc. Okay, I think that's all the questions arise from this from today's seminar. We already answered and already discussed from our two speakers. And for me as a moderator right here, I would like to wrap up a little bit. So the collaborative working in many many aspects, many professions is needed to overcome this IMR, antimicrobial resistance issue, which is of course globally, it become a global issue right here, and we cannot stand up alone. We have to hand to hand working together to work these things out. And since, if I'm not wrong, Dr. Anis said there's no available new antibacterial was found for the last 20 years. I think the research like Prof. Nora did, how to found such a new compound, a novel compound that hopefully can be used in the to overcome this antimicrobial resistance is a very, very good and hopefully it's very promising for us. And I don't know, is there something that I like here? How about the industrial? Is there? Sorry, Prof. In Indonesia, maybe it's very hard for us to get support from industry. How about in Malaysia on your own project itself? Is it difficult to get support from industry to develop new compound of this antimicrobial, so we can hand by hand together to overcome this IMR.
We just started with the industry collaboration now, but for those the biosensor things, so it's starting to, maybe the industry start to look for our research nowadays. So it's starting giving some fund, giving some expertise, and giving their facilities. Yeah, inshallah, in the future, in the very, very near future.
Yeah, thank you, Prof. Yeah, hopefully this also can be applied here. Through this seminar, maybe there's industrial, I guess there's several people come from industry, from vendors of laboratories, equipment, something like that. And if I'm not wrong, there's some people that I knew that also joined. And at the end of the seminar now, today, I apologize if there's any words or my behavior is mistakenly taken. I'm sorry, I didn't mean to do that. And hopefully this seminar can bring a new insight, also enlighten to all of us that this IMR is a hot issue, hot topic aside the COVID right now. I'm happy to moderate this seminar because this is new, a little bit bored with COVID issue personally, but yeah, this is so enlightening and I'm so happy to be joined here. Thank you very much to Prof. Nora, to Dr. Anis. I give the time now to Master of Ceremony, Dr. Isti. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Dr. Fitria, for guiding the discussion from both speakers. And finally, we come to the end of this event. Alhamdulillah. And thank you so much to all the speakers and also the moderator for sharing their knowledge. And I also send the regards and sorry from Professor Ina because she has to leave earlier because she has another meeting this afternoon. And then to all the participants, we also thank you for your coming and your nice hearing here. See you again on the next Forum Biomedika. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam.
So thank you, Professor Nora.
Yeah, thank you very much. It's so great pleasure for me. Yes, a great pleasure for me to see all of the faces, students, and Dr. Anis as well, Dr. Fitria, Dr. Isti.